Okay, logicians, this is 7D ITT Set 1, number 2, as per request. So here we've got our compound statement. It's not the case that if H, then if Q, then R. So as per usual, we've got on the far left, we've got the 3 columns set up that schematically give us the truth values of each of the simple statements, all the possible combinations. And then each of these truth values is reproduced underneath the appropriate letter on this side under the compound statement. And our job is to figure out the truth value of the whole thing in each of these circumstances. So the first rule about which of these logical connectives should we start with, like which of the question marks should we figure out first, you want to go as far inside the parentheses as possible. In that case, that takes us straight here, and then you work your way out until you get outside the parentheses. So we're going to start here, then we'll go here, then we'll go here, because you have to know this in order to figure out this. You have to know this to figure out this. So let's start with if Q, then R. Now, you might have found this difficult because horseshoe is one of the logical connectives that people find confusing. You might just have to memorize the truth conditions. What you do have to memorize the truth conditions for all the logical connectives, but especially with horseshoe, you're going to need to focus on this one. Here's when horseshoe is true. If the antecedent is true and the consequent is true, like in this case, if true, then true, then the horseshoe is true. Here's the only circumstance in which horseshoe is false. When the antecedent is true, but the consequent is false. That's the only line, the only kind of condition under which horseshoe is false. That's false. But, and here's what's going to screw you up in your mind. When the antecedent is false and the consequent is true, horseshoe is true. You might ask why. Watch the video, read the book, but basically, in this circumstance, the conditional is not falsified, so it's still true. And the same holds true is the case when the antecedent is false and the consequent is false. Conditional is not falsified, so it's true. Again, you might just have to memorize that. But if you know that, then the rest of this becomes easy. So we got true, true is true. True, false is false. False, true is true. False, false is true. Okay. Now let's look at this next horseshoe. Now, in order to evaluate it, we're going to look at the H column for the antecedent. But what's the column we're going to look at for the consequent? It's not the Q, which is right next to it. It's the horseshoe, because remember, the consequent is this whole statement, which is contained within the parentheses. And the truth value for the whole statement is given by the truth value of the horseshoe. So you're going to be looking at antecedent, consequent. So line 1, we've got if true, then true. That's true. Line 2, if true, then false. What is it? False. Line 3, if true, then true is true. If true, then true is true. If false, and I don't even care what the rest of these say, because if the antecedent is false, horseshoe is true. Okay, now we are ready to move outside the parentheses to the main operator. How do I know this is the main operator? Because it's the one logical connective which ranges over the entire statement. Like this negates everything inside the brackets, which is everything else. Also, if you remember Sasser's corollary, one of Sasser's tips is the main operator will never be inside parentheses. It has to be outside parentheses. And therefore, since this is the only logical connective, which is outside parentheses, highlight that thing because that's the main operator. All right, how do we determine the truth value of a tilde, of a negation sign? Well, it just reverses whatever it's ranging over. And so, and what's the column that we're going to be looking at? Don't look at the H column. We don't care about the truth value of H. We care about the truth value of this, everything that's inside the brackets, which is given by the horseshoe. All right, because the horseshoe tells us whether the whole if then of everything that's in the brackets is true, right? So if If this is true, then the negation is false. If this is false, negation is true. And you can see the rest of these are true under this column, so it's going to be false the rest of the way down. And you're done.